Alright, so this is for section 10.1.7, exercise 1G, question 9. Block of land is illustrated on this simple map, and the ratio is 1:100, so 1 unit is 100 metres. So I'm not sure if that's the correct way to write the ratio there, but let's just move on anyway. 1 unit represents 100 metres we can work with. Find the perimeter of the block to the nearest metre. Finding the length of each side will get us there pretty quickly. How are we going to do that? Like most of these things, you can use your distance formula. What is your distance formula? It's really just Pythagoras' theorem. So it doesn't bother me which way you want to do it. If you want to show you're working like that, or if you just want to use the distance formula, either one will work fine. That side length there, well, that's pretty easy. That's just 5 straight across. So we can get 5 units for that. And what's 5 units equal to? That's 500 metres. Second one here, I've got 1, 2, 3, 4 units down, 1 unit across. If I whack that into a bit of Pythagoras' theorem, I'm going to get that that distance is root 17 units. Now, okay, so that's equal to exactly 100 root 17 metres. Is 100 root 17 a particularly useful value in this one? Well, if we read the question, it says that we're to answer to the nearest metre. So I would suggest we actually get out a calculator or something and figure out what that's roughly equal to. Now, I'm trying to do that here on the computer at the same time as doing this, so eventually got it to work. 412.31. is the approximate length of that side. Last one, I've got 1, 2, 3, 4 going down, 1, 2, 3, 4 going across. If you know your Pythagoras' theorem really well, you'll know straight away that that's 4 root 2. You might remember that from your trigonometry with your 45 degree triangle. If not, whack it into Pythagoras' theorem, you'll get the same answer. So 4 root 2 units, which is equivalent to, multiply by 100, I've got 400 root 2 metres, and we need to find out what that is. 400 multiplied by square root of 2, getting the approximate value here, 565.69 metres. So to find the perimeter, I simply add those together. 500 plus 565.69 plus 412.31. 1465, 1477, 1478, something like that. I better check that on my calculator just to make sure I'm doing the right thing. 565.69 plus 500 plus 412.31, 1478. I don't know what I said before. I don't know that it was that, so let's just get that. 1478, 1,478 metres is the perimeter of the block to the nearest metre. The next one's interesting. The block is split up into 4 triangular areas by building 3 fences that join the midpoints of each of the sides of the block, and then find the perimeter. Well, let's scroll down a little, and we've got some room here. So the midpoints, first thing you've got to do is find the midpoint. So this one is at -2, 2, and over here I'm at the point 3 and 2. Using my midpoint formula, 3 and -2 is 1, divided by 2, that's going to be the midpoint, and it occurs at 1/2, and obviously the y coordinate hasn't changed, it's a 2, that's pretty easy. The next one, 4 down, 4 across, so the midpoint 2 down and 2 across, it's at the origin, that's nice and easy. And the third side, I go across 1, so halfway, that's going to be at 2.5. or 2.5, and it looks like it's on 0 as well. 2 below, 2 above. I know I've got it right. So what they're saying is they're breaking the paddock up into 4 areas that look roughly like that. Let's find the length of that perimeter. Now you could use a little bit of logic and work out which sides are corresponding to which and possibly find some similar triangles in there if you're lucky. But let's assume you just want to go with the distance formula, find the distance for each one and figure them out. Well, distance along the bottom, it's a nice horizontal line. It goes from 0 to 2.5. So that distance is 2.5. That's pretty straightforward. This one here, I've gone from 0, 0 to 1/2 and 2. So the distance, I'm going to call that one D1. D1 squared is going to be the difference in the x coordinate squared and the difference in the y coordinate squared. Because it's got a half in it, I just want to make sure I get it right. 1/2 minus 0 squared plus 2 minus 0 squared. So this is the distance formula again in case anyone's forgotten it. That's the square root of 1/4 plus 4. D equals the square root of 4.25. Wow, what's the square root of 4.25? Would help if I knew how to use a calculator. Don't use one often enough. That's going to be approximately 2.06 units, which is approximately equal to 206 meters. This one over here, I forgot to say that was in units, which is approximately 250 meters. This remaining side, I'm going to call D2, which means this one's D3. That's fine. D2. What am I doing writing squared over there? We already know that that's not squared because I've got it in the distance formula, so it's just the square root. So this time D2 equals the square root of, how far across have we gone? Well, we've got 2.5 minus 0.5. That's the difference in my x coordinates. Squared plus 0 minus 2 all squared. D2 is going to be equal to 4 plus 4 root 8 or 2 root 2. Which, if we do that, it's going to be 200 root 2, or in meters, multiply it 200 by root 2, I get 282.84. So the perimeter, 206 plus 282.84 plus 250. And I get the approximate perimeter to be whoa, that's a mess. 738.84 meters. So to the nearest meter, 739 meters. Alright, I hope that helps. Cheers. Oh, I just signed off and said cheers, but I remembered I was going to tell you that there was an easier way we could have found that without having to go through all that distance formula. Let's go back up here and look at this triangle. You can see that I have congruent triangles, triangles that are identical, by looking at either of the parallelograms. Which ones do I mean? I could look at that parallelogram there. Clearly that's been cut in half by that diagonal, so the two long sides are equal to the other two long sides. Ah, so they must be equal in length. If I choose a different, no, it's not letting me, oh yeah, there we go. If I look at a different parallelogram, I can see the two outside lines are equal to the two other ones there. That also means that those side lengths are going to be equal. I've got congruent triangles. And finally, there's a third parallelogram there that I could draw like that, which again would give me congruent triangles. So what I'm going to find is that I have, in the larger blue triangle, two of each of the sides in that small triangle. This side here appears once over there, and once over there. The blue side that I'm going to label here appears once on the outside of that triangle and once down here. They're all the same length. And if I take a green pen, this side here, well, that appears once in that triangle. Oh, I think I labelled the blue one wrong there. And once in that triangle, the blue one I meant to label that one over here. That gets it. So this one, the blue one, appears once on the left there and once down the bottom on the left. The red one with one dash appears once over here and once over there, and the green one appears once there and once there. You can see that every side of that red triangle appears twice in the larger triangle. So if I just halved the perimeter of the larger triangle, which was 1478, I believe, I'll get the perimeter of the smaller triangle, 739. Now I think I'm done. Thanks, guys.